I am so heated right now. I just recorded an entire video for you guys, and this stupid owl camera was activated. So when I went to play it back, all you could hear was. It was horrible. It felt like I was at the dentist. So I'm going to do this video again. I just took 14 minutes to record it, and now I'm going to take another 14 minutes and record it. If you hear the bell ring, that means I'm late for community time. I'll probably get in trouble, even though I'm sitting here working hard for you guys. So life is tough, you know? But I had a great intro on the other one. And basically what it was is we're going to focus in on parabolas right now. And you think you know everything about parabolas, but guess what? You don't. We're about to go on a deep dive. We're going to learn new terms. We're going to complete the square in a really tricky way. We are going to have to memorize this formula. Like, you know that parabolas are y equals x squared. Like, that's what you're used to. But there's a lot more involved, actually. So let's start with some terminology. Okay? Parabolas, every parabola has an axis of symmetry. That's what cuts it in half. It's perfectly symmetrical. It has a vertex. That's the lowest or the highest point of the parabola. And there's two new terms. There's this new point, which is called, it's a fixed point, called a focus. And then there's this line here. It honestly should be a dashed line, to be real. It's not really going to show up, but it's just understood to be there. That is called the directrix. And here's what a parabola is. Don't miss this. Okay, this is what actually makes a parabola a parabola, is that every point on this thing, over here, the vertex, is equidistant from both the focus and the directrix. Let me say that again. Every individual ordered pair around this parabola is equidistant from the focus and the directrix. Here's what I mean. This point over here, we'll call it point number 1. Whatever that distance is, let's say it's 6 centimeters or something like that. This distance is also 6 centimeters. You see that? The distance from an ordered pair, in this point, we'll call it point A. The distance from point A is equidistant from the focus and the directrix. Excuse me, the focus and the point, and the directrix and the point. Okay, and the vertex, this guy right here that I'm circling in green, it's exactly halfway between your focus and your directrix. So if you know where your focus is and you know where your directrix is, you know where your vertex is. All right? So that's some new terminology that we are going to use. You got to be comfortable with. The focus is the point. Think like focal point. The directrix is a line that helps determine your direction. Is it opening up? Okay? Is it opening down? If it's opening up, then the focus will be inside, the directrix will be underneath it. If it's opening down, the focus will be inside, but the directrix will be above it. What if it's opening left? Yeah, we'll talk about that. The focus is inside of it, and the directrix is over here. And if it's opening right, the focus is once again inside of it, but the directrix will be over here. So those are going to be our 4 options. It's either going to open up, down, left, or right. In order to know which, we have to be comfortable with both of these formulas. Okay? Got to be able to identify and memorize this. Y equals 1 over 4c. That's the new part. Okay, this is the part that helps us find the focus and the directrix, so that's new. But the other part you should have seen before. H and K is just like your vertex, right? The vertex would be H comma K. Over here, the vertex would be still H comma K, but notice how the H and the K are switched. Why are they switched? Because when you have a Y equals parabola like this is opening up or down like normal, but we're also going to deal with X equals parabolas, so those are going to open left or right depending on if this is positive or negative. Okay, positive opens to the right, negative opens to the left. Just like positive opens up and negative opens down. Okay? We're getting after it. We are getting after it. So let's talk about this little C value. The C value is the distance from the vertex to the focus. That's the C value. And the distance from the vertex to the directrix. The focus is always inside, we talked about that, inside the parabola. Okay, so let's talk about that. What's the C value? The C value is this. It's important to know. Let's use red. This distance right here, the distance from that focus to that vertex, that's C. And also, this distance right here, the distance from that vertex to that directrix, that's also C. C is the distance from the vertex to the focus, or the distance from the vertex to the directrix. All right. Let's do some examples here. I'm not going to refer to this box, but if you're a steps person, I think it's great. I'm going to spend some time explaining how we need to get the equation in standard form. That's where we complete the square a little bit. We have to move some things around. That's kind of tricky algebra. But then the rest of this, I'm hoping we feel familiar with it. Determine whether it opens up, down, left, or right. Find the vertex. Find the C value. Draw the parabola, so on and so forth. Okay? Let's start with some examples and see if this comes to life here. Find the vertex, focus, directrix of a parabola, and here it is. They gave us the parabola. I like purple better. Y equals 1/2 x squared. Okay? Well, here's what you need to know, where you need to be able to write it on command. This is a y equals, so the standard form is y equals 1/4c times x minus h squared plus k. You just need to be able to pull that out right away. Okay? Because now you can look and see this doesn't have an h or a k. So the vertex must just be at 0, 0. It doesn't have any parentheses, any shifts, so it's right on the origin. So we took care of the vertex. As for the focus and the directrix, we need to find C. We need to find this. That is the key to finding both the focus and the directrix. So check this out. If we know right here there's a 1/2, and we know right here there's a 1/4c, what if we just said 1/2 equal to 1/4c, and we work backwards to find C? It's a little proportion, will do the trick. Cross multiply, 1 times 4c is 4c, 1 times 2 is 2, you divide both sides by 4, and c equals 1/2. So we now know what our C is. That is not our focus, but that's going to help us find the focus. Because if we know that our parabola has a vertex at 0, 0, and we know that it opens up, how do we know that? It's a y equals and it's positive, so we know that it opens up. Then we know the focus must be right in here. And the directrix must be right below it. And since C is 1/2, the focus is just going to be 1/2 up. So what would be 1/2 up? That would be 0, 1/2. That's that coordinate right there. And then what's 1/2 down? The directrix is going to be y equals negative 1/2. Notice the directrix is written as a line. The focus is written as a point. That's important because they're different. So that is the focus and the directrix. So there is our answer for example 1. I want you to see, pause the video if you need to, but the key is knowing the standard form and then finding your C value. Knowing standard form, finding C value. Let's do the next one. It says find the standard form of the equation of a parabola with the vertex at 0, 0 and the focus at 0, 2. So they actually give us the vertex here. Switch to red. They give us the vertex and the focus. So let's get a visual. Vertex 0, 0. Focus at 0, negative 2. I'll label that F for the focus. So what does that tell us? We know which way that opens now. It's going to open down. We also know our C value. What is our C value? Well, 1, 2. It's the distance right here. That's the C value. So C is 2. since it's going down, it's going to be -2. I know distance isn't negative, but we want to make sure that's a negative so that when we write our equation in standard form, it's going down instead of up. So then we also know where our directrix is. That's at y equals 2. So I think we have everything we need, because our standard form, I'll just write it again to help you memorize it, is 1 over 4c times x minus h squared plus k. Got to memorize that. So now we can just take our c value, which is -2, plug it in right there. And then our vertex is 0, 0, so both of these h and k's are going to be 0. So our final answer is actually going to be 1 over -8 x minus 0 squared plus 0. You don't even need to write those zeros, though. You could have just written it like this. That is a parabola in standard form with a vertex of 0, 0 and a focus at 0, -2. Okay, last problem. And I know I'm going fast, but it's because you can also slow down the speed at the bottom, or you can rewind, but I want you to feel prepared for tomorrow to hit the ground running. So here's the last one. Back to purple. It's what if it looks like this: x squared minus 2x minus 16y minus 31 equals 0. This is not in standard form. If it's ever not in standard form, your immediate go-to should be completing the square. But this is different than circles, because you're not going to complete it twice. You're just going to complete it once, but you got to decide which one you're going to complete it on. So you have to look and decide, is this going to be a y equals parabola or an x equals parabola? And the way you determine that is you look for which one doesn't have a squared term. This 16y, there's no y squared on there. So we need to, it's going to be a y equals at our final answer. And we're going to complete the square with this part. Okay, so let's just start doing some stuff. We need to get this by itself so we can complete the square. So I'm going to move the 16y and the 31 over to the right side. So if we do this, I'll leave some space to complete the square. 16y plus 31 are over here. We ignore them for now because we need to complete the square, right? So what's half of 2? That's 1. Squared is 1, so we add 1 to both sides. The reason we did that is so it can now turn into x minus 1 squared. And so even after that one step, you see how we're closer to this? It's starting to take shape. We at least have a parentheses squared now. But notice, we need to get y by itself. Right here, y is not by itself. So our last two steps will be to subtract this 32 over and then divide everything by 16. So if I subtract the 32 over, it would be x minus 1 squared minus 32 equals 16y. And when you divide everything by 16, your final answer would be 1 over 16, x minus 1 squared. Dividing by 16 is the same as multiplying by 1 over 16. 32 divided by 16 is 2. We'll leave it negative. And 16's cancel. And so here is my standard form of my parabola. It's in y equals form, so I know it's opening up or down. We can find our vertex because it's going to be h, which is 1, and k, which is -2. We just need to go and find that c value so that we can then find our focus and our directrix once you find the c value. Okay, what is the c value? 1 over 16 equals 1 over 4c. You can just do simple math and know that c is 4. So our focus, if we do a little sketch here, the vertex is at 1, -2. We know it opens up. The focus is going to be 4 higher. There's our focus. The directrix will be 4 lower. So if the vertex is at 1, -2, the focus would be at 1, 2. And the directrix would be at y equals -6. I had to hurry because we're running out of time. Please rewatch the last few problems of this video. I want to help you tomorrow, but you got to watch this again maybe to be ready to hit the ground running because there's a lot of new terms and tough stuff. See you tomorrow.